Rockets utilize the fundamental principle of physics known as thrust to propel themselves through the vacuum of space. This thrust is the force generated by expelling mass at high velocity in the opposite direction, as per Newton's third law of motion. At the core of rocket propulsion is a propellant, a substance that can undergo a chemical reaction and release a substantial amount of energy. Most rockets use a combination of fuel and oxidizer as the propellant. The fuel provides the chemical energy needed for the combustion process, while the oxidizer supplies the necessary oxygen for this combustion. In a rocket engine, the fuel and oxidizer are combined in a controlled combustion chamber. The chemical reaction between these substances produces a high-temperature, high-pressure exhaust composed of hot gases. These gases are then expelled through a nozzle at the back of the rocket at extremely high velocities. The rocket nozzle plays a critical role in shaping the exhaust gases to achieve optimal thrust. It's specifically designed to accelerate the gases to achieve a high exhaust velocity, which directly impacts the thrust generated. According to the rocket equation, thrust F thrust F thrust is determined by the mass flow rate of the expelled propellant. As the rocket expels mass at a high velocity through the nozzle, the resulting reaction propels the rocket forward. The larger the mass of propellant expelled per second and the higher the exhaust velocity, the greater the thrust produced. In the context of flight, rockets must overcome the gravitational pull of celestial bodies like Earth to ascend. Initially, at lower altitudes, the rocket faces increased resistance from the denser atmosphere, but as it ascends and the atmospheric density decreases, efficiency improves. Guidance systems within the rocket continuously adjust the direction and intensity of thrust to steer the rocket accurately and achieve the intended trajectory. These systems utilize sensors, onboard computers, and control mechanisms to ensure the rocket stays on course and reaches its desired destination.